All right, kids, so we have a test on what we've been working on tomorrow, and I'm going to do one problem from each section of the test. This is obviously a test from last year, and take a look at it. Here we go. Write the correct formula. Well, we've done a lot of work on that. See, vanadium 1 nitrate. I'll pick the hardest one. So we know that vanadium is +1. We know nitrate is -1. So, well, it's just VNO3. All right. Label is soluble or insoluble. All right. I'll do the first one, silver sulfate. So we're looking on top of page 6, and we look at our sulfates. It says all sulfates are soluble, okay, except calcium, strontium, barium, and silver. So that's cool. That was an exception. That is insoluble. All right, insoluble. All right, then we have a balance section. So balance and label the type. So we got 3, 3, 3, 1, right? And we can look back and see if they're right. See, I started out, I saw there were 3 nitrates there, so I put a 3 there for the nitrates. And this is a double replacement reaction. All right, look at the directions for this section. Just circle the precipitate or anything that is made in the test tube. So precipitates include anything insoluble or water or gas if you want to do that, but I won't pull that. So we'll look at the number 26 here. So we need to see which one of these, if either, is insoluble. So our choices are copper 2 chloride or sodium nitrate. Well, all nitrates, they're insoluble. So we know it's not that. So let's look up copper 2 chloride. All chlorides are soluble, and there's no exception for copper. So in that problem right there, you wouldn't have circled either one of them. All right? On the back of the test, finish and balance and circle the precipitate. All right, no reaction. This is a single replacement. First, we need to see, would potassium replace magnesium? We very simply looked at our list of cool kids here. We say that potassium is higher than magnesium. So yes, now you would have potassium with oxygen, and that formula would be K2O. And then now the magnesium's by itself, all right, and that would be a solid. So we could just circle that one. That's what we would make. Okay, and then we would balance it. So we need a 2, looks like 2, 1, 1, 1. All right, so finish, balance, and circle the precipitate, or write NR if there's no reaction. I would also label that as aqueous probably. All right, next section. Finish and balance and circle the precipitate if there is a reaction. So these are double replacements. Now this one's harder because you have to write the formula. Sodium carbonate, Na2CO3, that's sodium carbonate, and magnesium fluoride. See why I needed you to have passed that naming test? So you have to do that just to get started. Let's switch partners. Now we would have sodium with fluoride, and that's the formula for that. And now we'd have magnesium with carbonate. Oh, my pen is hitting the thing. That's funny. All right, so at this point we need to say, hey, are either of these a precipitate? Sodium fluoride we'll look up on page 6. All fluorides, and there's no, so yeah, it's soluble. And then now we're going to look up magnesium carbonate. Under insoluble, all carbonates are insoluble, so boom, that is the precipitate. We'd label that PPT. This is aqueous. Again, sorry, I'm hitting the phone with my pen. And then we'd have to balance it, finish and balance. There's 2 sodiums there. We need a 2 there. That gives us 2 carbonates. No, no, excuse me, children. I messed that up. There's 2 sodiums there, so there's a 2 there, which gives us 2 sodiums and 2 fluorines. Well, look, there's a fluorine there, so we're 1, 1, 2, 1. So look, these are hard, and you'll have several like this, where you have to do the whole thing by yourself. And then down here at the bottom, there's a thing that we're going to do today called net ionic equations, and they're very easy. And that lesson will come out in just a little bit.